Good morning, students. Our topic is evaluation of a bounded plane area. So, using integration, today we are going to find area of the bounded region. Okay, you see that first one, area of the region bounded by a curve x-axis and the lines x is equal to a and x is equal to b. So under this topic you are having two cases. So first we are going to see the first case. We are going to find the area using integration. So that area of that region, it is bounded. Okay, how it is bounded? Bounded by the curve y is equal to f of x. Bounded by one curve. The second one, x-axis, one axis, and the ordinates, otherwise the lines, the ordinates, x is equal to a and x is equal to b. Okay, so one side the region is bounded by the curve, next side it is x-axis, and it is between the lines x is equal to a and x is equal to b. So this area lies above the x-axis, means the formula in A, that is A means the area of this bounded region is equal to integral a to b y dx. Okay, you see the diagram here, x-axis and y-axis I have drawn, it is intersects at the origin. Here the shaded part is the bounded region. This bounded region, this region is bounded by one side the curve. So this curve is y is equal to f of x. Okay, one side the curve y is equal to f of x. Next side the x-axis. So x-axis here it is given, and the lines x is equal to a to x is equal to b. So this is the line x is equal to a. Okay, and this is the line x is equal to b. You see that four-sided the region is bounded. The region is bounded by one side the curve. So the curve, another side by x-axis, and the lines or the ordinates x is equal to a and x is equal to b. If you want to find this area, you have to see where the area is. It lies above the x-axis. You look at your ordinates, it varies from x equal to a to x equal to b, means you have to choose x-axis. In that x-axis where the area above x-axis, means you have to use the formula integral a to b y dx. You see the next case. See, area of the region bounded by the curve y is equal to f of x, x-axis, and the ordinates x equal to a and x is equal to b. This is lies below the x-axis. Lies below the x-axis means your area is equal to integral a to b minus y dx. Okay, area should not be negative, so it has to be written within the modulus. Otherwise, you have to use the formula integral a to b minus y dx. You see that this diagram, this area, shaded part is bounded by the curve y is equal to f of x. And one side it is x-axis. The next lines, you see that this is x is equal to a and this is x is equal to b. This shaded region is bounded by the curve y is equal to f of x, x-axis, x equal to a and x is equal to b. But this area of the region below the x-axis, so you have to use integral a to b minus y dx. Otherwise, it's a modulus of integral a to b y dx. So the area lies above the x-axis. If the limits varies from x equal to a to x equal to b, means integral a to b y dx. The same area lies below the x-axis, means you have to use the formula integral a to b minus y dx. Next one, area of the region, second one, area of the region bounded by a curve, now y-axis, and the lines y is equal to C to y is equal to D. We are going to see under this also you are having two cases. You see that now here we are considering the y-axis and the lines y is equal to C to y is equal to D. Okay, see now area of the region bounded by the curve x is equal to g of y. Okay, so the previously we have taken y is equal to f of x, here x is equal to g of y. And y axis, the lines y is equal to C and y is equal to D. What is here? You are having y is equal to D. Y is equal to C and y is equal to D. This bounded region lies to the right of y-axis. So see that it looks above x-axis also there, but lies to the right of y-axis. If you consider the limits varies from y is equal to C to y is equal to D. If you are considering the limits in terms of y, and you have to see whether the area lies right side or left side. If it lies to the right of y-axis, the area is equal to integral C to D x dy. It is positive. You have to take the positive x. You see the diagram. So here this is the curve. So what is the curve? X is equal to g of y. And you are considering y-axis. One side y-axis. And see that limit y is equal to C. This is the lower one. So y is equal to C to y is equal to D. This line y is equal to C and this line is y is equal to D. This region, how it is? It is to the right of y-axis, means you have to write the area integral C to D. What is it? X dy. The same area lies to the left of y-axis. You see that area bounded by the curve x is equal to g of y. And what axis? Y-axis. And the limits varies from what is it? Y is equal to C to y is equal to D. Y is equal to C means this line and y is equal to D means this line. So this region is lies to the left of y-axis, means your area is integral C to D minus x dy. Otherwise you have to write modulus of integral C to D x dy. Okay, so this is the four cases you are having in area. See the exercise 9.8. First one, find the area of the region bounded by 3x minus 2y plus 6 is equal to 0, x is equal to minus 3, x is equal to 1 and x-axis. Okay, you see that this is the line given. Okay, it's a linear equation, so it is the line, straight line equation. You see, instead of curve you are having line and the axis x-axis, and limits varies from x equal to minus 3 to x is equal to 1. You see the line x is equal to A to x is equal to B. But you are going to choose x-axis. So x-axis means you have to consider whether the area lies above x-axis or below x-axis. Okay, see whatever it is, first we have to draw the diagram. Then only we can understand whether the area lies above or below. Okay, so for that you consider the line. Okay, so in that you have to consider any 2 points on the line. So for that, so I will consider the line. So here x and y, put x is equal to 0. If you put x is equal to 0 means you know where it touched the y-axis. If you put y is equal to 0 means you can find where it touches the x-axis. You can find y-intercept and x-intercept. It is easy for us to draw the line. So put x equal to 0. In that if you substitute x equal to 0, you are getting minus 2y plus 6 is equal to 0. So therefore 2y is equal to 6. So y is equal to 3. Next put y is equal to 0. Here you just substitute. Put y is equal to 0. So this term will become 0. So you are getting 3x plus 6 is equal to 0. 3x is equal to minus 6. x is equal to minus 2. So this is very important, these 2 points. Then only we'll know where it touches the x-axis and y-axis. After finding these 2 points, you can substitute any value for x plus 1 and go for minus 1. Put x is equal to 1. So here you are having 3. 3 plus x is 9. So when you take it to the next side, it is minus 9. So minus 2y is equal to minus 9 means y is equal to 9 by 2. Okay, in this way you can find some negative values. Okay, so see that using this, we are going to draw the diagram. First, x-axis and y-axis has to be drawn. Next, you have to draw the line. For that, what point first? 0, 3 approximately. So here 0, 0. So 0, 3 will be here. This is the point 0, 3. And next one, what it is? Minus 2, 0. So x-axis la minus 2, this is this length. So minus 2, 0, it will be marked in the left side of x-axis. So it is enough to draw the line using these 2 points. So you know that this at this point the line touches the y-axis. At this point the line touches the x-axis. Using these 2 points, using scale, you draw the line, extend the line. Okay, so this line equation is drawn. Next one, what it is given? X-axis. Already x-axis is drawn. Next you have to draw the lines. What lines? X is equal to minus 3. So see that x-axis, x equal to minus 3 means you look at the x-axis. Here the point is minus 2. So next one be minus 3. So this is minus 3, 0. Using that, you have to draw the line. So this is your x equal to minus 3. And next what it is? X is equal to 1. So x is positive. Go to the right side of x and you draw the line x is equal to 1. You see now, first you have to draw the, what is it? X-axis and y-axis. Okay, x-axis, y-axis. Then you have to draw the line. So the line point is 0, 3 and minus 2, 0. So using these 2 points, using scale, you draw the straight line. Okay, next, after that, this line is drawn. Already x-axis is there. You have to go for x is equal to 3. So this point is what? Minus 2, 0, this point. So therefore x equal to minus 3 will be here. So you have to draw the line. So whose equation is given, so you have to draw the straight line. X is equal to minus 3. That has to touch the line. Otherwise you just extend the line. Next, x is equal to 1. So it will be in the right side. So you draw the line which is parallel to y-axis and it has to touch the line. Okay, then you just name everything. So first you have to mark the line. So the line equation is, what is it? Here you just mark, what is it? 3x minus 2y plus 6 is equal to 0. So this is the line. This is the line. And the x-axis is already marked. Next, what is it? This is x is equal to minus 3. And this is your x is equal to 1. See now, the line x-axis, x is equal to minus 3 and x is equal to 1. So the area should be bounded because 4 region is given. So here if you take this part, so the line is there, x-axis there, x equal to minus 3 and x equal to 1 is not here. So bounded region. So this part and this shaded part will come under this bounded region. So one you name as A1, another one, this part you have to name as A2. Look at this, both the part is needed. So the required area is what? You have to mention this is A. So A is equal to A1 plus A2. Both the area is under the bounded region. Okay, so A is equal to A1 plus A2. But here your A1, where it is? It lies below the x-axis. Why we have to choose x-axis? So your lines is given, the limits are given in terms of x equal to minus 3, x is equal to 1. So if the limits are in x, you have to choose the x-axis. If x-axis is chosen, you have to see one area, that is A1, is below the x-axis. If it is below the x-axis, how to write the formula? Integral a to b minus y dx. Okay, and the second one, a2, how it is? This part is a2. Okay, so this a2, how it is? It lies above the x-axis. So therefore a2 formula is integral a to b y dx. So I have written what is a1, what is a2, what formula has to be used. Next I am going to find the area. So a1, so you take a1, so a1 is this part. Okay, so the lower limit is, what is it? X equal to minus 3, and where it has to stop, it is over at the point minus 2 comma 0. Okay, so therefore the limits varies from x is equal to minus 3 and x is equal to minus 2. So it varies from minus 3 to minus 2. What is it? A1 lies below x-axis, so it is minus y dx. Okay, so the y has to be found. That y has to be taken from the line or given curve. Here the line is given, so from that only we have to consider. So you consider the line equation, and minus 2y you take it to the right side, it will become plus 2y. So from that y is equal to 3x plus 6 by 2. You can have as it is, so I divided by 2. I take a separate term, so for that it is easy for us to do the integration. Okay, so 3x by 2, that is 3 by 2 into x, plus 6 by 2, what is it? It is 3. So it just substitute in a1. So minus 3 to minus 2, minus, this minus is common to both the terms, so minus of 3 by 2 x plus 3. So in the place of y, I have substituted this value into dx. You see your y is in terms of x, so that's why y dx. Okay, so this minus is taken out completely. You go to the first term, you are going to integrate. 3 by 2 is a constant. What is the integration of x? Using the power rule, that is x power n plus 1 divided by n plus 1. So that is x squared by 2. And go to the second term, it is a constant, that is 3 dx. So your answer is 3x, the integration is 3x. And you have to apply the limits. So limit varies from minus 3 to minus 2. You see that the minus is in the front, so for the minus you are opening the bracket and you are going to apply the upper limit. So it is 3 by 2. 2 2s are 4, so 3 by 4. In the place of x, if you substitute minus 2, the whole squared is 4 plus 3 into minus 2 I have written. So upper limit is over. Next you have to write the minus. Then you have to apply the lower limit. So in the place of x, you have to substitute minus 3 the whole square, that is 9. So into 3 by 2 2s are 4 plus 3 into minus 3. So minus is written out. So this 4 and this 4 getting cancelled. So here the first term having 3. So minus is written, first term is 3. And here 3 into minus 2, what is it? It is minus 6. At the next one, minus in between you are having 3 into 9 is 27 by 4. So here you are having 27 by 4. And 3 into minus 3 is minus 9. So it is written minus 9. So 3 minus 6, when you calculate, it is minus 3. You have to take LCM. 9 4s are 36. 27 minus 36 by 4. So the answer is minus 9 by 4. So minus into minus plus 9 by 4. If you take LCM, it is minus 12 plus 9. What is it? Minus 3 by 4. In the front, you are having minus. So minus into minus 3 by 4. So we have found A1. The area is 3 by 4 square units. Next you have to find A2. How is A2? It lies above the x-axis. So therefore integral A to b y dx. So see the diagram. You have to find out the limit. So A1 starts from this line, x is equal to minus 2, and end with x is equal to 1. So therefore the limits varies from minus 2 to 1. So you have to write minus 2 to 1. Y already we have found from the line. So that is 3 by 2 x plus 3 into dx. So when you integrate, so the same thing will come. You have to apply the upper limit and the lower limit. In between you have to write minus. So when you calculate, you have to take LCM. 12 plus 3, that is 15 by 4. Here 3 minus 6. Okay, so that is minus 3. So minus into minus, what has to come? Plus. If you take LCM, 15 plus what is that, 12 by 4. So A2 is 27 by 4. So what is the required area? You have to add both of them, A1 plus A2. So what is A1? It is 3 by 4. You look at your area is not negative. So it is 3 by 4 plus 27 by 4. That will be 30 by 4. 30 by 4, if you simplify, 7 4s are 28. Remaining is 2. So 5 4s are 20. Thank you, students.